A voltage source in series with a resistor R is identical to a current source in parallel with the same resistor. This is called source transformation. For the two configurations to be identical, the condition is that Ohm's law must be satisfied. Is must be Vs over R, which means that Vs must be R times Is. Let's take a look at this example. Say we want to find the voltage Vx, the voltage across the 10 ohm resistor. We can use source transformation to achieve this. The question is, should we transform the source that's on the left or the source that's on the right? Well, Vx is on the right, so we want to preserve that branch. So let's transform the voltage source on the left. We have a 1 ohm resistor in series with the source. So this can be transformed to a current source of 10 over 1, which is 10 amperes, in parallel with the 1 ohm resistor. We can then combine these two resistors in parallel. The result is a 5 over 6 ohm resistor. The next step is to look at this current source in parallel with the resistor and transform it into a voltage source in series with the same resistor. 10 times 5 over 6 is 25 over 3. So this is the equivalent circuit. We now have these two resistors in series, so adding them results in 17 over 6. And now, once more, we'll look at the voltage source in series with the resistor and convert them into a current source in parallel with the resistor. 25 over 3 divided by 17 over 6 results in 50 over 17 amps. The next step is to look at these two resistors and combine them in parallel. And this would not result in the Vx voltage being lost, because these two resistors are in parallel, so they share the same voltage, meaning that once we combine them in parallel, the voltage across this 170 over 77 ohm resistor would still be Vx. The final step is to combine the two current sources because they feed the resistor in the same direction. We can combine them into an 84 over 17 amp current source, and then Vx can simply be found by multiplying the current with the resistance. So Vx would be around 10.9 volts. So the voltage Vx across the 10 ohm resistor in the original setup is 10.9 volts.